buoyant force is the force that a fluid exerts on an object that is immersed within it. It is called buoyant force because the force is a lifting force, often making the object buoyant. Buoyant force can be calculated using Archimedes' principle. Again, for an excellent transcript and possible free video resource, click this link. The magnitude of the buoyant force always equals the weight of the displaced fluid. The buoyant force is the same for a totally submerged object of any size, shape, or density. The buoyant force is exerted by the fluid. Whether an object sinks or floats depends on the relationship between the buoyant force and the weight. The upward buoyant force is called the buoyant force labeled B. It is equal to the density of the fluid displaced, rho times gravity times the volume of the fluid displaced, which is also equal to the volume of the totally submerged object. The downward gravitational force is a measurement of the weight of the object. Mass times gravity, or in terms of density, the net force is the difference between the buoyant force and the weight. Sinker or floater? That is the question. After watching the following video and thinking about the previous pages about Archimedes, do you understand why the eggs behave the way they do? Notice the free body diagram drawn for the totally submerged object. If this is the actual force experienced by the block, then the block will accelerate upward because the buoyant force is larger than the weight. Sometimes, no matter how hard you try to sink something, it will float back to the top. Notice the free body diagram drawn for the totally submerged object like the previous page. In this case, if this is the actual force experienced by the block, then the block will accelerate downward or sink to the bottom, because the buoyant force is smaller than the block's weight. Sometimes, no matter how hard you try to keep something afloat, it will sink back to the bottom. In a floating object, the object is in static equilibrium. The upward buoyant force is balanced by the downward force of gravity. Volume of the fluid displaced corresponds to the volume of the object beneath the fluid level. Research on fuel efficiency oftentimes includes having cars placed in wind tunnels. Additionally, the concepts behind wind moving across turbine blades is a fundamental that all wind technicians should know and understand. When a fluid flow becomes irregular, it is called a turbulent flow. Oftentimes it exceeds a certain velocity, and really any condition that causes abrupt changes in velocity is considered irregular. Also, eddy currents are a characteristic of turbulent flow. Note the basic difference between streamline or laminar and turbulent flow. Here's an interesting pair of videos that show turbulence and comparisons to laminar flow. Watch them and think about how this could affect the rate at which turbine blades can turn through the air as wind is blowing against them. In the 1950s, television viewers were awed by the dropping of a pearl in Prel shampoo. What was so special about Prel? It was a shampoo with more viscosity than normal shampoos. Viscosity is the degree of internal friction in the fluid. The internal friction is associated with the resistance between two adjacent layers of the fluid moving relative to each other. Watch the 1950s commercial and then watch the additional video that discusses viscosity. This is one where a college physics class did some experiments with dropping an object in 3 different fluids. The results are shown. For a fluid to have the characteristics of ideal, the fluid is non-viscous. It is incompressible. It is steady. And the fluid moves without turbulence. Here is a favorite children's book by Dr. Seuss. Do you know much about oobleck? If you are interested, here is a great blog that explains some physics about oobleck. Finally, here is a clip from the popular TV series The Big Bang Theory. In this episode, you see the science gang working with a non-Newtonian fluid, oobleck. Environmentalists are very concerned with the conservation of water. Low-flow shower heads can be used to reduce the overall water output from your shower. You could even stop the flow entirely with the shut-off button. Remember that the product of the cross-sectional area of a pipe and the fluid speed is a constant. This is the equation of continuity. You can also control the irrigation rate for your yard or garden using the principles of the equation of continuity. See how you can reduce the area of the valve and get a greater velocity of water to shoot out the end of the sprinkler hose. Our understanding of the Bernoulli process is the major reason why we understand flight. Since the fluid, in this case air, has to remain in a non-turbulent steady-state manner, something has to change. The result of the higher velocity going over the top of the wing as compared to the bottom of the wing path is to make a lower pressure on top of the wing and a higher pressure on the bottom of the wing. With a pressure gradient present, lift will be formed because the high pressure region is trying to come to equilibrium with the lower pressure region, and a force of lifting occurs. Bernoulli's equation states that the sum of the pressure, kinetic energy per unit volume, and the potential energy per unit volume has the same value at all points along a streamline. So the fact that these terms are conserved means that an airplane will be able to go into flight as long as the pressure differences are great enough to provide the needed lift to the plane. Pressure on the area of the wing creates a force. This force, when unbalanced, will create an acceleration or a lift on the wings of the plane. A Venturi meter shows fluid flowing through a horizontal constricted pipe. The speed changes as diameter changes. It's used to measure the speed of the fluid flow. Swiftly moving fluids exert less pressure than do slowly moving fluids. The larger the velocity through the tube, the less pressure that is measured. It is a fact because of the conservation law associated with Bernoulli's equation. Many of the next topics are covered during a more advanced course in physics. The pages will have minimum explanation of the mathematics, but hopefully can help an advanced student gain a little extra insight into the world of fluids and fluid dynamics. Surface tension is the reason why a water bug tends to stay on top of the water. The net effect of this pull on all the surface molecules is to make the surface of the liquid contract. It makes the surface area of the liquid as small as possible. For example, water droplets take on a spherical shape since a sphere has the smallest surface area for a given volume. In this image, surface tension allows the needle to float even though the density of the steel in the needle is much higher than the density of the water. The needle actually rests in a small depression in the liquid surface. The vertical components of the force balance the weight. The surface tension is defined as the ratio of the magnitude of the surface tension force to the length along which the force acts. SI units are newtons over meters. In terms of energy, any equilibrium configuration of an object is one in which the energy is a minimum. The surface tension of liquids decreases with increasing temperature. Surface tension can be decreased by adding ingredients called surfactants to a liquid. Here's an interesting set of videos which helps to explain the process of adding a surfactant to a liquid to decrease the surface tension. Watch how a simple single drop of soap will cause an object to stop floating. Cohesive forces are forces between like molecules. Adhesive forces are forces between unlike molecules. The shape of the surface depends upon the relative size of the cohesive and adhesive forces. In this example, the adhesive forces are greater than the cohesive forces. The liquid clings to the walls of the container and the liquid wets the surface. This example shows cohesive forces are greater than the adhesive forces. The liquid curves downward and does not wet the surface. In image A, phi is greater than 90 degrees, and cohesive forces are greater than adhesive forces. In image B, phi is less than 90 degrees, and adhesive forces are greater than cohesive forces. Capillary action is the result of surface tension and adhesive forces. The liquid rises in a tube when adhesive forces are greater than cohesive forces. At the point of contact between the liquid and the solid, The upward forces are shown in the diagram. Here, the cohesive forces are greater than the adhesive forces. The level of the fluid in the tube will be below the surface of the surrounding fluid. The height at which the fluid is drawn above or depressed below the surface of the surrounding liquid is given by the following. Viscosity refers to friction between layers. Layers in a viscous fluid have different velocities, and the velocity is greatest at the center. Also, cohesive forces between the fluid and the walls slow down the fluid on the outside. When discussing the coefficient of viscosity, consider the following. Poiseuille's law states, the velocity of the steady flow of a fluid through a narrow tube varies directly as the pressure and the fourth power of the radius of the tube, and inversely as the length of the tube and the coefficient of viscosity. In other words, it gives the rate of flow of a fluid in a tube with pressure differences. Reynolds number is a dimensionless quantity that is used to help predict similar flow patterns in different fluid flow situations. At sufficiently high velocity, a fluid flow can change from streamlined to turbulent flow. The onset of turbulence can be found by a factor called the Reynolds number, or Rn. In what is called transport phenomena, the movement of a fluid may be due to differences in concentration. The fluid will flow from an area of high concentration to an area of low concentration. The processes are called diffusion and osmosis. In diffusion, molecules move from a region of high concentration to a region of low concentration. The basic equation for diffusion is given by Fick's law, where d is the diffusion coefficient. In this image, concentration on the left is higher than on the right of the imaginary barrier. Many of the molecules on the left can pass to the right, but few can pass from right to left. There is a net movement from the higher concentration to the lower concentration. Osmosis is the movement of water from a region where its concentration is high, across a selectively permeable membrane, into a region where its concentration is lower. A selectively permeable membrane is one that allows passage of some molecules but not others. When an object falls through a fluid, a viscous drag acts on it. The resistive force on a small spherical object of radius r falling through a viscous fluid is given by Stokes' law. As an object falls, three forces act on the object. As its speed increases, so does the resistive force. At a particular speed, called the terminal speed, the net force is 0. This concludes Lesson 15. In this lesson, you covered the following objectives.